welcome to part 2 of the AICE math review for limits. We're going to start with the definition of a derivative. Alright, so in the next video, we're going to talk about derivatives, but the definition of a derivative uses the limit, okay? It's essentially the limit as h approaches 0 of f of x plus h minus f of x all over h, okay? The reason why is because the derivative is the slope of a curve at a specific point, at one little point. And so you can't technically find the slope of a point, you need 2 points. But if you put the points really close together, this is what h is. H is basically 0, but a little bit bigger. And so you're putting those 2 points really close together, and as h goes to 0, that little fraction is going to be small. Well, kind of small, okay? So f of x plus h is like your y2, f of x is your y1. H, all it is x plus h minus x. X plus h is your x2, and x is your x1. So all this is your slope formula, but written in a different way, okay? And yeah, so let's use the definition of a derivative to find the derivatives of these numbers. Now notice this looks like an f1 of x, but it's f prime. That's how it's read, f prime of x. That's your derivative of x. And so that's the notation. So basically, we have our function a of x, and it's equal to 3 of x. So what is a prime of x? Well, plug everything into here. So remember, always write limit as h approaches 0, okay? Always write that, because if you don't, then it's technically wrong and your teacher might reduce points, ours would. So, so f of x plus h, so this is 3 times x plus h, because that's what we input, so this is going to be 3 times x plus h minus 3x, that's just your f, and then all over h, which is, we don't know what h is, so it doesn't matter, h is going to eventually be 0. So all this is the limit as h approaches 0 of 3x plus 3h minus 3x. This 3x and that 3x are going to cancel. Obviously, on your exam, you should show all of your steps. You should expand this out and then cancel it. But just for the sake of time, I'm going to be quick about this. So this 3x cancels with that 3x. And we only have 3h over h. These two h's cancel. And we're left with the limit as h approaches 0 of 3, which we know is just going to be 3. We don't even have to worry about it. So notice that the derivative of a constant times x is always going to be your constant, okay? Just know that, okay? And the derivative of a constant is 0. It's kind of wacky to use the formula with it, so don't worry about it. So now x squared, okay? So this is the limit as h approaches 0 of x plus h squared. So we can just expand this as just going to be x plus h times x plus h minus, so x squared. Okay, so this is x plus h squared all over h. So this is just the limit as h approaches 0 of, okay, x squared plus 2xh, or hx, whatever you want, plus h squared minus x squared all over h. So this x squared and that x squared cancel. All of these terms have an h, so you can cancel this with that, and then one of those, and you're left with the limit as h approaches 0 of 2x plus h. And then if that approaches 0, that's just going to be 2x. Now notice, I don't want you to mess this up. Show this in 2 steps. Don't cancel the x squareds and the h's in one step. Cancel them in separate steps. Separate steps, okay? So I only showed like 3 steps here. Show like 5. Alright, we are almost done. We just have this. Now this looks easy, but it's, we have to cubed x plus h, and you'll see why. So limit as h approaches 0 of 2 times x plus h cubed. So we're going to have to do x plus h times x plus h minus 2x cubed all over h. Now I'm just going to do x plus h to the side because it's kind of weird. So x plus h squared, that's pretty easy. It's just 2, x squared plus 2xh plus h squared. And we are just getting this times x plus h. So let's just do all of this. This is x cubed plus 2x squared h plus xh squared plus hx squared plus 2xh squared plus h cubed. Okay, that was a lot. But then we just, so we take, so then we have to multiply everything by 2 and then subtract 2x cubed. So all that is, so if we multiply this by 2, so I'll just do 2 times all of that, that's going to be a huge number. Okay, but we know that 2x cubed is going to cancel out, so this and this are going to cancel, and so we're left with, okay, so all the h's cancel out, and each of these terms has an h, which is good. This h cancels completely, one of those, that completely, one of those, and then one of those. Okay, so with that, so this is the limit as we still have to do the limit as h approaches 0 of okay, so we have 2x squared, 4x squared, because we multiplied by 2, 4x squared, and then this xh, so plus 2xh plus that h is gone, so then 2x squared, and then 2 times 2xh is going to be plus 4xh plus this h squared, or 2h squared, and we don't actually divide by h anymore because we already did that. Okay, so now, well, let's just plug in 0 for all of them because I think we've simplified it enough. So if this goes into 0, that's gone, and that's gone. Okay, and we're left with 4x squared plus 2x squared, which is 6x squared. Alright, now we have two functions. You can put it in the same limit. You can do 1 over x plus x squared, or 1 over x plus h squared minus 1 over x plus x squared, or minus x squared, all over h. But let's just separate it into two limits so it's easier for us, because you can do that. If you have, so the limit of two functions can be split into two limits of each function, so that's what's cool. So we can write this as, oh my god, the limit as h approaches 0. I'm going to do this 1 over x. This is 1 over x plus h minus 1 over x all over h plus the limit as h approaches 0 of x squared. So this is x plus h squared minus x squared all over h. Okay, plug in 0 in any of these, you're going to get what's called an indeterminate answer. 0 over 0, infinity over 0, infinity over infinity, 0 over infinity. Those are all indeterminate answers. Okay, so what do we do? Well, x plus h, and then we have this x here. You can try to combine like terms, but that's kind of weird. So we're going to multiply all of this by x times x plus h. All right, so I'm going to take this, and we have x times x plus h, and so we don't change the value of the expression. I'm also going to do x times x plus h on the bottom. Okay, that's a lot, but yeah, so then we have, So x times x plus h divided by x plus h, that's just going to be x. So remember, limit as h approaches 0 of x minus x plus h. And if you want to work through that, you can. And then hx, I'm not going to simplify this on purpose, okay? This x minus x cancels out. This h cancels that h. Again, show those in two different steps. We're left with 1 over x times x plus h. And if h is 0, so this is just x times x, so that gets rid of, again, show that in a third step. X times x is x squared, so we're left with x squared, but we're not done. I'm sorry, no, x to the negative 2, because this is 1 over, so this is x to the negative 2. Hold on. No. This is a minus, because minus distributes, so this is negative x to the negative 2, because that's a negative right there, okay? Just make sure you're doing it right, okay? And then we have this plus, limit as h approaches 0 of this. Well, this is just x squared, so we have, so limit as h approaches 0 of x squared plus 2xh, so x squared plus 2xh plus h squared minus x squared. These two cancel, again over h. These h's cancel, and we have 2x plus h. I already did that one, so that's why I'm going through it pretty quickly. This turns into 0, and we are left with a plus 2x. I'm just going to write that here, plus 2x. And this is the derivative of